What I'll do now is probably go a little more into the technology part as well as the people part. Moving to the technology, yeah, so, the page here depicts one, typical kind of architecture or ecosystem. Again, in no way the stack is really a recommendation, and it's very important that for a particular requirement, somebody really thinks through and finds out what's the right, set of what's the right architecture and set of tools which is required to be put in together. But then this is just an illustration. But what it says is that there are various components which are really coming in place for making an overall solution. The solution might need something for keeping the data in the best possible way, to being able to query from the data, to being able to create a data flow around it, coordinate between different structures. When you have structured data, unstructured data, when you have data which is voluminous or real time, non-real time, there are various different dimensions based on which you take a decision on what should be the right architecture you should put in place for your big data problem. Now, and on top of that, as I talked about, is a lot of this is ever changing today. And tomorrow, if we look at any of this, there might be a better solution available on any of these different names. And there are companies who are working on streamlining it. There are companies who are probably putting many of them together and creating a bigger, more commercialized kind of architecture and selling. But then, what's important from a practitioner's viewpoint is that it has a diverse set of components, and the expertise might not really reside with one person, and it might be highly distributed in nature. You might be having somebody who really understands how to keep the data in the best possible way, but then you might have completely a different person who has much better understanding of maybe machine learning to be done on top of that, on top of that architecture. So that creates a huge issue in terms of, what technology, how we pool all of these technologies together, how do I get the type of people, and how do I really bring together a team which can really, handle this complexity together. And on top of that, how do I really keep in touch with newer things which are coming in place, which might be even more effective than what we are seeing today. Staying on that point, going to the next page is, I'll just wait for the page to refresh. But this is like a very usual and simpler view of distributed processing, or maybe Hadoop kind of setup. And I know there have been a couple of webinars which has touched upon on what's Hadoop and how it works. And I'm not going to really go very deep into technology, because that's not the intent for today's webinar, and we can probably talk at length at a different webinar. But if you look at a very simple view which talks about how we take the data and kind of split it into different small pieces in the best possible indexing, through a best possible indexing, and then how we map them together, how we put them all together again, and finally get some numbers. And now if you look at it, this is like an example which has been beaten to death by several people, because this is probably the first project or first exploratory project which many of us do when we start working with maybe Hadoop, which is like creating the word count program, which is like number of times a particular word has really come in a set of texts. Now you basically start with a large amount of text. You split this whole data into maybe several number of small machines, and calculate in each of these machines certain numbers and in terms of their frequencies, and then again kind of get them together and finally have a consolidated number. Now this looks, though it looks simple, but it might not be as simple as what it looks. But still, this is like a very simplified view of what distributed processing can be, because the problem in today's world might not be as simple as calculating number of times a word has come. Many of the problems of today, what's being really worked out, or in many cases what's being taught, is really related to counts and averages and sums, which because of its own nature makes it much more distributable. But then when you think about a more advanced kind of techniques like machine learning, like statistical modeling, that's where you have to really think through how you distribute that. It's not inherently distributable. Now let me see probably one specific type of problem in the next page, which we in Bridge I2I deal with. It's basically a credit card authorization systems. Now, as and when you swipe your credit card at any merchant's outlet, there is the data is really being fed into a decision engine, which has information about the merchant, where this transaction is happening, the type of transactions, a lot of information about that individual, type of things being bought, and that decision engine, for all practical purpose, looks through this data and takes a call whether there is a high chance of this particular transaction being a fraud transaction or not. And then it either accepts or decline, in some cases also refer, where somebody else kind of talks to you and checks whether the transaction is really genuine or not. And then finally, that creates a huge amount of data. You kind of track these individuals whom you have accepted and see whether some of them have finally resulted into fraud or not. Now, when you look at creating a decision engine like this, it basically is dealing with a huge amount of data. You can always take a small sample of the data, like any other statistics problem really deals with. But then when you take a very small sample of the data, what happens, such frauds are not very common in nature. So, you might not really get a good representation of data. And then, with big data coming in place, with newer technologies, we can really, think about, beyond sample and probably use much larger amount of data. And we're talking about several terabytes of data being used, because every transaction, every swipe you make is really one point of transaction. The second part is that as you see, when you swipe the card, immediately, within probably few seconds, it takes a decision and tells you whether it's accepted or not. And hence it has to be really an algorithmic solution. And the algorithm need to be really, taking the call in a much more real time. And it doesn't, you cannot really have an individual sitting and taking a call, because the whole world will stop otherwise. And the third part is that, when you talk about any of these algorithm, because frauds are changing, because every day people are doing newer types of frauds, it has to have a self-learning mechanism where it is learning from any new frauds which are coming and kind of updating itself. Now that's really a much more complex system in a big data setup. In the next page, I'm just waiting for the page to come up. In the next page, we're talking about what's the way we can really solve such kind of problem. Either using statistics or using machine learning. Now, one can be that you have some set of frauds, and which these are known frauds. So you try to figure out what are the transaction patterns which led to some kind of fraud. So you have the transactions which are frauds and some of them which are not, and then you try to figure out how they are different. And the second aspect is that what are the anomalies in the data? You know how people should ideally behave, and do you have an outliers which do not behave like the way others are behaving, and that kind of gives you a feel of what can be an outlier and probably potentially frauds. But then the next question which really comes is that it's not really a count problem, it's not really a sum or average problem. It's a problem where I have to, for all practical purpose, build some machine learning techniques to identify, to categorize data into frauds, non-frauds, and inherently, can that computation be really distributed? And how can we really make it much more self-learning so that it can pick up as and when new frauds are coming? Now that's where I would say a lot of newer innovations are happening or need to happen in next few years to come. Obviously, there are libraries like Mahout and others which many of us use, but then there are newer techniques. All of us are also finding out our own way of exploring and figuring out how such methods can be really distributed, and probably some of them will remain as IPs for many of these organizations. Hopefully, some of them will also be contributed back to the community, so that the